Now let's consider the following question. Evaluate the function f of r equal to the square root of r plus 8 minus 6 given the values of the independent variable, and then simplify. All right, let's go ahead and solve this. The function f of r is given by the square root of r plus 8 minus 6. Letter A, we want to evaluate f at negative 8. So what does that mean? That means that you have to replace the r here by negative 8. So we have the square root of, replace r by negative 8, then copy the plus 8, minus 6. So negative 8 plus 8 is 0. That means the square root of 0 is 0, minus 6. So the answer is negative 6. So that's letter A. F of negative 8 is equal to negative 6. Now for letter B, we want f of 28. So f of 28. Again, our f of r is equal to the square root of r plus 8 minus 6. We want to evaluate f at r equal to 28. So that means you replace the r here by 28. So you will have 28 plus 8 minus 6. Now, square root of 28 plus 8, 28 plus 8 is 36. So that is equal to the square root of 36 minus 6. And what is the square root of 36? 6 minus 6. That is equal to 0. So therefore, f of 28 is equal to 0. Now, letter C. For letter C, we want to evaluate the function at x minus 8. So you were given f of r equal to the square root of r plus 8 minus 6, and we will replace, since we want to solve for f of x minus 8, we will replace our r in the equation here by x minus 8. So we have x minus 8 in replacement to r, and then you copy plus 8. So you copy plus 8 minus 6. So this is equal to negative 8. Negative 8 plus 8 is 0. So that gives us x only inside the radical sign. Minus 6. So therefore, f of x minus 8 is equal to square root of x minus 6. Let's consider another example. We have to evaluate the function f of x equal to x squared plus 6x minus 8 at the given values of independent variable and simplify. So copy over here. So here we are given a quadratic function. So our function f of x is x squared plus 6x minus 8. Now, if we are asked to find f of 6, that means we are going to replace the variable x here by the number here. So we're going to replace x by 6. So we have 6 squared plus 6 times 6 minus 8. And then you simplify. 6 squared is 36 plus 6 times 6 is also 36. So 36 plus 36 is 72 minus 8 is equal to 64. Letter B. We are to find f of x plus 3. So this would mean that we would replace x here in the expression for f of x by x plus 3. Okay, that means you evaluate the function f at x plus 3. So in other words, you will have replace x by x plus 3 quantity squared plus 6 times, again replace that by x plus 3, then minus 8. Okay, then now when you simplify, you will have to expand this. So expand this, you have, so using the formula, you have x squared, or you can use the FOIL method. This will be expanded as x squared plus 6x plus 9. And then this will be distributed to each term in the parentheses. So plus 6x plus 18 minus 8. And then you simplify by combining similar terms. This is equal to x squared plus 6 times 6 plus 6 is 12x plus 18 minus 8 is 10 plus 9 is 19. So that means f of x plus 3 is equal to x squared plus 12x plus 19. And similarly, for letter C, what this means is that you replace the x here by negative x. So you have letter C, f of negative x is equal to negative x quantity squared plus 6 times negative x minus 8. And then you simplify it. Negative x quantity squared is just equal to x squared. And negative x times 6 is negative 6x. Then you copy negative 8. So this is the expression for f of negative x. Now let's consider the next example here. In this example, we are given a graph of the function f of x, and we are asked to find the value of, in this case, f of 5. So we want f of 5. So let's go ahead and expand this, or you can click on that one to make the graph bigger. All right, so we want f of 5. So that means you just look for x equals 5. So you locate x equals 5. So this is 1, 2, 3, 4, and that's 5. So if you want f of 5, so you want to know what the value, the y value of the function when x is equal to 5. So you locate the point on the graph where x is equal to 5, like this case here. And so this is this point. Now that pertains to y equals 3. So in other words, when x is equal to 5, f of 5 is just equal to 3. Similarly, if you are given another graph here, and then this time you are to find g of 6. This is the graph for the function g. You want g of 6. That means you want to know the value of the function when x equals 6. So this is x equals 6. You locate the point on the graph. This is this point here. That's the g of 6. And then you get the corresponding y value. And that is equal to negative 9. Now, for the next question here, we are given the graph of the function. Now, we would have to identify the function's domain, the function's range, the x-intercepts, if there's any, and y-intercepts, if any, and the function values at f of 0 and f of 4. Okay, so I copy that over here. So this is what we want to determine, the function's domain, given the graph here. So to get the domain, whenever you are looking for the domain, you would think of it as the collection of x values. So you would have to collect all the x values of the function. And the range would be the y values. Okay, so for the x values, you just look at the values for which there is a graph of the function. So notice here that your graph actually extends up to negative infinity. So it goes, the arrow here means the line goes up to negative infinity and it does not end. And similarly here, this part of the graph continues to go to negative infinity without end. So that means that for any x values, there would always be a graph. There would always be a graph of the function. So that means that the domain of the function is the set of all real numbers. We are asked to write our answer in interval notation. So that means negative infinity to positive infinity. Now, what about the range? Range would be the y values. So now you look at the y values for which there is a graph of the function. Notice that there's no graph here, and that is above this line here. That is when y is equal to -1. So you double check, is that really -1? So no, you count 1, -1, -2, -3, -4, -5. Yeah, so that coincides. So that means each grid here in this particular example is -1. So we have -1. That means there's no graph above that -1. So there's only graph from the values here, which is actually negative infinity. You always start with a smaller number. So that is from negative infinity up to, and there's only graph up to this point here, and that is when y is -1. -1. Now, very, very important. This means included. So that means it's closed at -1. There is a point, there is a graph at -1. So this notation here means not included. So if there's like a hole at that point, then you will not include that point. Okay. All right. So next, x-intercepts. So this is A, B. Now what about letter C? We're looking for x-intercepts. When you say x-intercepts, that's the intersection at the x-axis. Will the graph intersect, or does the graph intersect at the x-axis? No. So therefore, you would just say none. No x-intercepts. There's no intersection at the x-axis. Y-intercept means intersection at the y-axis. Again, so x-intercept, let's go back to that. X-intercept, intersection of the graph, intersection at the x-axis. And then y-intercept means intersection at the y-axis. So, does the graph intersect the y-axis? Does it cross the y-axis? Yes, it does. It crosses the y-axis at this point here. And what is that point? That is the point when y is -4. So letter D, we have the y-intercept. Y-intercept. If there's any. Now, if we're asked to write it as an ordered pair, then you would say x is 0, because at the y-axis, x is 0. And then what's the y value? That is -4. So it is at the point 0, -4. This is in the form of an ordered pair. So if you're just asked to find the y value for which the graph crosses the y-axis, then you would say y equals -4. But most commonly, you would be asked to write it in as an ordered pair. So now letter E, we want to find the function values of f at x equals 0 and f at x equals 4. So we want f of 0. That means we want to find the function value of f, the y value, when x is equal to 0. So when x is equal to 0, that is just the y-intercept, and that is equal to -4. And then next, we want f at 4. So that means we want to know the y value when x is equal to 4. So it's 1, 2, 3, 4. So this is 4. Look at go to the function. This is the point here on the function, and then get the y value, and that's -2. Okay, again, locate x equals 4. So you locate x equals 4. It is this point here. And then go point at the graph. Look at the graph. Okay, so this is the point on the graph where x is equal to 4. Now look at the y coordinate of that point. The y coordinate of that point is this point here, which is -2. Okay, so moving on, let's consider the question here. We are given the function f of x equal to x squared minus x minus 5, and also another function g of x, which is equal to 5x minus 4. Now we want to find g of 6. What does that mean? We want to evaluate our function g when x is equal to 6. And then next, you want to evaluate your function f at g of 6. So that means whatever result you will get from g of 6, you will then evaluate your function at that value. All right, so to answer this, we will have to find g of x first. So g of 6. G of 6, that means you replace your x in g of x by 6. So you have 5 times 6 minus 4. 5 times 6 is 30, minus 4 is 26. Then next, you want to find f of g of 6. But what is g of 6? We already got a value for g of 6, and that is 26. So this means that this is just equal to f of the value we got, which is 26. So that means you evaluate the function here at x equals to 26. So that is 26 squared minus 26 minus 5. And then you can plug this into your calculator. Now, plugging this into my calculator, this is what I got. I got 645. So f of g of 6 is equal to 645. This next question, we are asked to determine whether the graph of the equation is symmetric with respect to the y-axis, the x-axis, and the origin. More than one of these or none of these. Now to do this, we will have to examine the equation here without actually graphing it. Okay, so I went ahead and copied that. Now, let's review. The graph of the equation is symmetric with respect to the y-axis if for every point xy on the graph, the point -xy is also on the graph. So what does that mean? That means that to check if it is symmetric with respect to the y-axis, you just have to replace x by -x and then see if you get the original equation back. So in other words, you want to know whether f of negative x would still be equal to f of x. So again, to check letter A, let's see, it is symmetry on the y-axis. With respect to the y-axis, so what you would do is replace x by negative x. So you have negative x to the fourth times y to the fourth plus 4 times negative x, y equal to 6. And then you simplify it. See if you get the original equation back. If you have negative x raised to an even power, that is just equal to x itself. So that will just be x to the fourth, y to the fourth, minus 4xy equal to 6. So notice that in here, you were not able to get the original equation back. This became negative and the original is positive. So this means that this is not symmetric with respect to the y-axis. Okay, so let's check whether it is symmetric with respect to the x-axis. So to do that, we will have to replace this time y by negative y. And then if we get the original, okay, so y by negative y, and see if you get the original equation back. If you get the original equation back, then that expression is symmetric with respect to the x-axis. So again, here for that part, you would have to negate your function, so, or replace the y by negative y, and then see if you get the original expression back. So to do that, we will have to replace your y by negative y to the fourth power plus 4x times negative y minus 6. Again, this would just be x to the fourth, y to the fourth, minus 4xy equal to 6. And hence, we did not get the original equation back. This is negative, that is positive. So this is not symmetric with respect to the x-axis. Now, thirdly, we would have to see if is this symmetric with respect to the origin. Because there are some cases wherein the function is symmetric with respect to x or to y or both, or it could also be that they're not symmetric with respect to the x or to the y-axis, but they're symmetric with respect to the origin. Or it could be that the function is not symmetric to any of these at all. Okay, so now, how do we check whether the graph is symmetric with respect to the origin? This time, we are going to replace both x and y by negative x and negative y. See that? So and then if we replace the equation by negative x and negative y and we get the original equation back, then that equation is symmetric with respect to the origin. So again, the graph of an equation is symmetric with respect to the origin if for every point xy on the graph, the point negative x, negative y is also on the graph. To check that, you just replace both x and y by its negative. Okay, so here we will have negative, so x becomes negative x, so negative x to the fourth times negative y to the fourth, also replace y by negative y, plus 4 times negative x times negative y, and see if you get the original equation back. So negative x to the fourth is x to the fourth. Negative y to the fourth is just y to the fourth. Then negative times negative, so negative x times negative y is positive xy. So plus 4xy equal to 6, which is just the original equation. So therefore, this one is symmetric with respect to the origin. And so in this case, we will just have to click on this one here, that button, and then that would be the answer. Okay. Now let's consider the following question. We are to use the following graph to determine the domain, range, x-intercept, y-intercept, the intervals for which the function is increasing, decreasing, constant, then the number of f at the number at which f has a relative minimum, the relative minimum of f, and then the value of f at -4, and then the values of x for which f of x is equal to -3, and then determine whether the graph is a graph of a function is even or odd. Okay, so I went ahead and copied that here. So let's go ahead and answer this question. Now, again, domain. What do you mean by domain? Those are the x values. So you look at the x values for which there is a graph of your function. And what are those values? In this case, we have that you have an arrowhead here, so that means it goes to -infinity, and there's also an arrow here, that means it extends here up to +infinity. So that means that the domain of your function is just -infinity to +infinity. Next, what about the range? To compute for the range, you look at the y values for which there is a graph of your function. So notice that your graph starts at this point here, and then it does not have a graph below that, but it only have a graph above this point here. Okay, so this means that the range, to look at the y function, the y values of the function, the range of your function is starting at this point, which is -4, and that is included. So -4 up to it goes to it extends up to infinity, so that means it goes to +infinity. That's the range. Again, I want to emphasize this means that it's close, it's included. If you put like this, -4 to +infinity, that is incorrect, because this means that -4 is not included. All right, so next, let's determine the x-intercept. X-intercept, meaning the intersection at the x-axis. So you identify where your graph would cross the x-axis. So letter C, x-intercepts. All right, so in this case, this crosses the point at x equals 3. So the x-intercepts would be at 3. I'll write it as an ordered pair. So 3, that means y is 0. And what else? The point, so this is the point 7, 0. So that is the point 7, 0. Or you can just say, if you're just asked to find the x values, then you just have to pick the x values. You're just going to pick the x coordinate and the y and the x coordinate. Okay, so these are the x-intercepts. You can either just write down the x coordinate depending on the instruction. So if it's asking you to just input the x values, then you just input the x values. If it's asking you to write it in terms of coordinate pairs, then you have to write it in this format. Okay, so next, what about the y-intercept? Here, you're for letter D, you're asked to find the y-intercept. When you say y-intercept, that is the intersection at the y-axis. So examine where your graph would cross the y-axis. The graph crosses the y-axis at this point, and that is the point when y is equal to 21. So here y is 21. You can say 21, or you can write it as an ordered pair, which you would write it as 0, x is 0, y is 21. This is how you would write an ordered pair. Next, we are to determine the intervals for which the function is increasing. Increasing, that means going up. So it's always from left to right. So from left to right. So letter E, you want the intervals for which the function is increasing. You examine the function from left to right. So let's look at from left to right. It should be rising. So it's going up. So is this going up? No, that's just steady. So at this point here, from here, there's a change in the graph, but it's going down. So that means it's not increasing. But here, from this point to here, it's going up. Now, when you write the interval, you always have to write it as an open interval. As an open interval. Again, as an open interval. So you would start at this point here. Start at that point. That is 5, open interval, starting at 5, going to positive infinity. That is the interval for which the function is increasing. Let me emphasize again, open. Write it open. Open interval. So open intervals. That's for both increasing and decreasing and constant. So again, if it's not indicated on, in the instruction, you just remember it should be open intervals. So that is for these 3 questions here. Those are the open intervals for which the function is increasing, decreasing, or constant. Okay, so decreasing. So that means when you say decreasing, it should be going down. So examine the function where it is going down. So we know that from this point to this point, the function goes down. So this is the decreasing portion. So that is from the point 0. Okay, again, open interval, 0 to, and it ends here because at this point it changes up to this point here, which is 5. So before that point, so that means open, 5. And then next, constant. You look at the interval for which the function is constant. Let me erase that part. Constant. Again, open interval for which it is constant. Constant meaning it does not go up or down. It is just a straight line, a straight horizontal line, which is this line here. And that is this interval. So there's an arrowhead here. That means it would start at negative infinity up to, so it's always from left to right. Negative infinity up to this point here, which is 0. Again, open interval. So that is the interval for which the function is constant. Next, the number at which f has a relative minimum. That means the x-coordinate at which f has a relative minimum. So it has a relative minimum in here, at this point here, and that is at x is equal to 5. That is where you have a relative minimum. Now, what is the relative minimum of f? What is the relative minimum of f? That means the value, the function value. So we want to know f of 5. What is f of 5? F of 5 is -4. And then, what is f of -4? That means you evaluate the function at f of -4. At f of -4, you locate x when x is -4, and you locate the y value. That is equal to 21. So f of -4 is 21. Next, we want to find the values of x for which f of x is equal to -3. That means this is the value on the graph. So look at the graph where it has a y value of -3. So this is negative, now that's -3. This is the point on the graph. Now you want to know what the corresponding x value when f of x is equal to -3. And that corresponds to this x value here, which is 4. So k is equal to 4. And then, is this function here even, odd, or neither? So to answer this, I guess you could ask yourself, how would you know by looking at the graph if the function is even, odd, or neither? Now, let's recall. A function is even if it is symmetric with respect to the y-axis. That means if you fold the graph along the y-axis, you're able to divide the graph symmetrically. Are you able to do that? The answer is no. So that means it's not symmetric with respect to the y-axis, so that means it's not even. Now, for odd number, or for odd function, we know that a function is odd if when we replace x by -x, again, so a function is odd function. If we replace x by -x, so that means f of -x, and you get the negative of the function, that means that the function is odd. So this means that the function is symmetric with respect to the origin. Now, is this function symmetric with respect to the origin? What does that mean? That means that if you replace, if you recall when it says symmetry with respect to the origin, if you replace x, you would have to replace both x and y by -x and -y, and you get the original function back. So that means for every function for every point on the graph, you get the corresponding, so for instance, this point here, -221. Do you get the point +2? Is the point +2 -21 also on the graph of the equation? The answer is no, right? So get this point here. If you look at that point, that is the point -2, +21. So then, if it is symmetric with respect to the origin, then the point +2, -21 should be on the graph. Is it on the graph? The answer is no. You don't even have a point, a graph below at y equal to -4. So this is not symmetric with respect to the origin. So it's not an odd function. So the answer is 9. Now in this question, we are given here a piecewise function. So the domain of the piecewise function here is -infinity to +infinity. It is divided at x equals 0. So when x is less than or equal to 0, your function is defined as -3x. And when x is greater than 0, the function is defined as -3. We are to graph the function, and then we would use the graph of the function to determine its range. Now, to do this, it is important that we have a good understanding of what a piecewise function is. Piecewise functions is sometimes known as a split function because a function is split into different intervals. Like in this case here, the function is split into 2 intervals. So the first interval is that less than or equal to 0, so that is -infinity to 0. So on that interval, your function is defined as -3x. So if you would graph it on that interval, on the interval -infinity to 0, including at x equals 0, when you graph it, you would just have to consider that line. So to graph a line, you would only need 2 points. So we could assign values for x and y. So if, let's say, because 0 is included, we can try with that. When x is 0, what is your y value? It is also 0. And then again, I find another point on this interval here. Get another point on that interval. So you could use -2. If x is -2, your y would be -3 times -2, and that is just equal to +6. So we have the point -2, 6. So first, so the 1.0, 0 is on that line, and then you locate -2, 6. So suppose this is 1, 2, and then 1, 2, 3, 4, 5, 6. So it is this point here. Then connect those two. Just put an arrow. So it goes there. Okay, so that is the graph on the interval from -infinity to 0. Now, what about on the interval greater than 0? So it says here on the interval greater than 0. So that means 0 is not included up to +infinity. Your function is defined as -3. F of x equal to -3, that means y is just equal to -3. So that is just a horizontal line. Excuse me. A horizontal line at y equal to -3. So that means you are going to do 1, 2, 3, -3. And then you have to put a hole here at x equals 0, -3, because x equals 0 is not included. So that means a hole on that part of the graph. Then you have this horizontal line here that extends also up to infinity. -3. So this is the graph of that piecewise function. Now, what about the range? And then what's the range? So you look at the y values. Your y values are just -3, -3, up to, what about here? There's no values. There's no graph but between -3 to 0, right? So that means -3, comma, so there's a graph there. And you have y starting at 0, including 0. You include 0 up to positive infinity, because this one is shaded, so that means it's part of the graph. So you have 0 to positive infinity as your range.